Good afternoon, ladies and gentlemen. Thank you first of all to Guy for inviting South Water to our first introduction to the Smart Water Networks, and indeed me personally for my first public presentation. So please bear with me and my good friend Nerves here. I was going to perhaps wax lyrical about the size of South Water's network, but indeed now I think after the 10th presentation I have network envy. We have a meager 780,000 customers compared to 14 million. Despite the size of the site internet, we all have one aim, and that is to have a continuous supply to all of our customers, which is a challenge in the West Country itself, because we have 4,000 square kilometres of area which we supply. It's all rural, so lots of long lengths of pipe with difficulties getting waters to the extremity there. But we also have, I think as Guy mentioned this morning in one of his presentations, we have a network there which we have much to thank the Victorians for, so unfortunately it's reaching the end of its life. We're then bringing a rather substantial capital investment strategy, which means the very work we are doing is intrusive and therefore affecting customer supplies. And as Kevin mentioned also earlier, we now have SIM, which has added a new dimension to the way our company is measured in terms of its performance, contacts in particular. So I thought I'd start by just crudely highlighting what the interruption lifecycle looks like for South Water. And it starts off obviously with an asset failure, which results in a service failure. And as I said, SIM is king. Service failures are what we want to avoid, and that might typically be by means of a burst, which results in a low water. We then do something reactively to mitigate that event, and that we'll come to a little later in the presentation, but that includes things like overland hoses, pumps, tankers. We then capture the data, we then do something with that data, ideally we secure some money to improve, we then end up with a proactive intervention, and finally a service improvement. And that's an iterative process that will go on forever for us, as long as we have a water network. And just quickly summarising here what this service improvement is multi-streamed, and these are kind of in hierarchical order here. But we start off with the cultural and process changes, essentially because they can be cheap. As long as you've got a robust change management process, you can instill new processes within your people to make a difference. And then we come to the reactive stage. There are things that South Water are doing, and I'm sure the other UK water companies are doing exactly the same, to mitigate those catastrophic failures that interfere with serviceability. Then we go on to the under-pressure technology, which is essentially tools. And finally the data bit, where we review, we learn, we improve, we report, and then ideally we're able to invest. So how does South Water compare relatively to the rest of the water and sewage companies? Well, you can see the little green highlighted area there is our greater than 6-hour interruption figure. It's really hard to read, but it's actually 0.042%. In real terms, that means we interrupt about 3,500 customers for more than 6 hours in the year 10-11. Well, that's a huge inconvenience, and it really isn't good enough. Only none is good enough for South West Water. Well, you mentioned SIM, so that's turned everything on head. It isn't really about just the numbers anymore, the cost. We now have an added dimension, which is customer perception. It isn't just how we feel services that we're providing for our customers, it's how they feel. And we are actually physically measured on the customer's opinion. So it's really important that we perform the best we can, and we capture that data, and we improve on how we do things now. So in short then, it's about keeping the water running. And in many ways, we are reinventing the wheel. It was mentioned today that we're trying not to do that, but this SIM arrival is really having to change fundamentally how we do business. And we're going to do that by a number of streams. We mentioned the business change, and essentially that's ditch tradition, embrace change. And then we're looking at much we've talked about today, certainly Kevin's presentation, is about our increased information that we're pulling back from the network, in particular real time. Let's get some heads up so we know things are going to happen before they do, and then we can proactively intervene. And my particular interest is the tools and technologies that enable us to do the work in the field. I'm just an engineer. I like boats, pipes and concrete. And then finally, a bit of added value really for this presentation, I have to admit kind of added in a little latterly, is about data capture, being able to contextualise that data, evidence it to make a business case to secure investment. And illustratively, I've highlighted some of the bits of technology which we will very briefly skirt through in the next couple of minutes to understand what we're doing operationally to mitigate planned and more significantly unplanned interruptions to water supply. We've mentioned SCADA a lot today, and in AMP5, Southwest Water has a massive investment project which we've coined PUROS, Phase Utilisation of Remote Operating Systems, a big project in excess of £35 million in the AMP. And this is where we're working on the generally good structure we have of our SCADA system and remote control and information feedback to build a system that is really robust and will improve our rankings. So, rather like Kevin again, we aim to be top of the pile in the water companies. In fact, comment on this on there, this is a broader strategy. It's really from source to tap and tap to environment. It isn't just water networks, but that's my particular bag. And speaking of my particular bag, in terms of operating the water network, I'm going to run through a couple of bits of technology we've been utilising in the last 12 to 18 months, which really has made a difference to our performance. We're all familiar, I'm sure, with a fire hydrant, perhaps not necessarily in the context of engineering, but for our fire services, a pretty vital piece of kit. But we have 45,000 of these units around our region, and traditionally we've never been able to replace or repair the piece of kit without shutting the water main down. There is now a piece of kit, which is illustrated there, and you can go to the website to look at it, that enables us to do just that. And we're forecasting a 60% reduction in supply interruptions associated with hydrants exclusively. Fantastic progress. And something which is slightly less technological, but I would perhaps argue more effective, and that is utilising overland hoses to maintain supplies when pipe supplies are off. Southwest Water has recently delivered about 12 of the units across our region, each containing anything between 200 and 500 metres of hose and other paraphernalia to enable safe and hygienic deployment of these hoses. And we are measuring the benefits. And in fact, in the month of September to date, we have seen 450 customers that would have had their supply interrupted had we not mobilised these facilities. And they're relatively cheap. And this is something I'm particularly interested in because this is my baby. This is a piece of kit that I developed personally. An interesting project because it's a mobile meter system. There are mechanics, there is electrical, and then control into this fancy little tanker, which is able to supply water at mains pressure to, well, it was originally scoped to maintain about 60 customers for 3.5 hours, domestic customers that is, and that was based on, that is about the average duration and scale of our emergency interruptions and indeed planned work. The testing was very successful. We actually managed to maintain about 110 customers through peak demand periods, breakfast and evening time. So on balance, about 7 hours for those 60. So a real great success. And we're proposing, after a successful trial, which I think we have already anyway, to roll out a fleet of these in AMP6. Back to the data. Out of the comfort zone now. Key to improving performance in supply interruption is indeed the data. We have an asset management team that feed this data into their models, which we'll come on to in a moment. And of course, we use the typical formulas of failure analysis, likelihood and consequence to dictate what interventions we might take. They are going to highlight. So working with Exeter University and Michelle's, we've developed a tool in-house that we use to prioritise our investment in our assets. And this is a very clever piece of software that looks at many millions of asset references, many feeds into the system, in particular the DG3 supply interruption data. And it gives us a heads up on where we might be looking at investment in the future. But the benefit to a small engineering team like ourselves is that it takes out that front-end expert judgment. It can narrow down the masses of data we acquire into where we might focus our investment and indeed apply that expert judgment before we spend or ask for money. And I have here a quick example of one of the model outputs, and it's looking specifically at asbestos pipe, which I'm sure is a national problem. But the data quite clearly indicates that in terms of the significant interruption band, which is greater than 6 hours, because that's a tangible measure of performance within the water industry, is that the materials in the 4-inch, 6-inch, 100 to 150 millimetre is where we should be looking to invest. So what about the future? Well, although you've seen from the earlier slide, we are pretty good, sitting at number 2 in the pile in terms of our unplanned interruptions. We do have a few gaps that we need to fill. And this has been talked about a lot today, and again I think I have some network modelling maybe now. But we don't have any real-time network modelling. We have a few modelers, but they're typically engaged in other activities. I think overall in terms of our performance we could see massive improvements if we were able to react in advance of failure. And finally, one which is a little bit off the wall, but certainly has a link to supply continuation, and that is the constraint around the off-rod structure for developer investment in the network. It's structured such that they can literally only pay for, and we can only afford to pay for them to have a water supply. There's no redundancy, there's no support or backup built into it. I think probably we're looking at a WRC type study for this. So in summary then, in my view, with a bias, there's no greater service impact than water supply interruptions. I'm sure the waste guys would have a different view on that. There are numerous operational actions that we can undertake to limit the extent of emergency failures, and we've looked at a few today, the tankers, the hoses. We really need to capture that data related to those failures so we can statistically model and come up with some pinpointed and effective and efficient investment to enable us to create a robust case that PR14 is approaching and moving forward so we can invest in assets and ultimately improve serviceability. Thank you.
Thank you very much indeed, Jason. I can't believe that was your first public presentation.
It was indeed.
It was from the